Chapter 7.3 is on graphing inequalities, and this is not that difficult. In fact, I'm going to show you a quick and dirty method for graphing inequalities as far as the linear portion of that is concerned. But when we go to graph inequalities, if you'll look on page 529, you'll see that all of those problems, you'll have something is either greater than or less than. And when you go to graph that, you'd graph it by indicating it with a dashed line. Those are my examples in the center there at the top. You'll also see that there are problems where it's either greater than or equal to, or less than or equal to. And when you get those symbols, when you go to graph the linear portion of your inequality, you'll want to graph it with a solid line. So let's go ahead and take a look at problem number 4. We're going to look at just a couple problems here, and then we're going to graph a combination of inequalities. Again, it's not going to be that difficult. When I have 2x plus y is greater than 6, I want to set up points which make it rather easy to graph. From this point on, what I like to do is set up the points x and y, where I cross the x-axis, and x is therefore 0, where I cross the y-axis, and therefore y is 0. Then I'm going to plot just those 2 points, and I'm going to draw my linear portion of my inequality. So if we have 2x plus y equals 6, and we put 0 for x, then plus y equals 6, then we'll get y equals 6. So we've got that point. Going back to 2x plus y equals 6, now if we substitute 0 for y, we get 2x plus 0 equals 6. 2x equals 6. 2x over 2 equals 6 over 2. And x is equal to 3. So there we've got our 2 points, and that's all we need. Now you noticed when I was solving it, I used the equals mark. That's okay. What I'm going to do now is go ahead and show you where that line would be. If the points were 0 and 6, that first point would be way up here. The second point being 3 and 0 would be down here. And when I went to graph that, because it happens to be a greater than but not greater than or equal to, I would do dashed lines. I'm just going to put some of those dashes in there, making it a little easier for me to erase when we do the next problem. And then I put my arrows in. That's the linear portion. But we have an inequality. So what we need to determine is when we're graphing an inequality, where do we shade? And so what you need to do is go back to the inequality itself. And this time what I use is the point 0, 0. I'll just use 0, 0. If I substitute in 2 times 0 plus 0 is greater than 6. Is 0 greater than 6? If it is, then you shade on the side with the 0, 0 point. But in this particular case, it's not greater than 6. That's not true. So when I go to shade, what I'm going to do is I'm going to shade everything on this side of that line. All right? And that's graphing your inequality. It's just that simple. We're going to take a look at 2 more examples, but as you can see, this is not that challenging. All right, we're going to try and carefully erase what we've got there so that we can graph another inequality without destroying our little graph. I'm sorry about that, but I don't have any other way of doing graphing. So let's take a look now, and I'll erase problem number 4, and we'll go down actually to the next page and look at problem number 14. This one has 3x plus y is greater than or equal to 6. All right? Again, when I set up my points, now all I'm going to do is I'm going to set up my axis points, x being 0 here, y being 0 there. 3 times 0 plus y is equal to 6, so y equals 6. That's this point. Then 3x plus 0 equals 6. So 3x equals 6. Therefore, 3x over 3 equals 6 over 3, and x is equal to 2. This is really quick and easy. Now those points turn out to be x is 0, y is 6. I think that's what we had before. And x is 2, when y is 0, that's down here. Now in this particular case, because what we had here was a greater than or equal to, that line should be solid. And I'll, for the most part, make this solid. So that's a solid line. That's, you have to use your imagination just a little bit for a solid line. Now when we go back, we ask ourselves, what about our 0, 0 point? Does 3 times 0 plus 0, is that greater than or equal to 6? Was 0 greater than or equal to 6? No, it's not. So again, our 0, 0 point being there, we're going to shade everything over here again. So you're beginning to think that's the only way it works. So we have to come up with an example of one that doesn't look like that. So let's go ahead and erase what we've got here. And let's try one more inequality. This time what we're going to take a look at is problem number 24. In problem number 24, it states 3x plus 5y is less than 15. Just looking at that less than, that means we're going to have a dashed line because it's not less than or equal to. All right, setting up our points now. X, y. If x is 0, then y is equal. Okay, 3x plus 5y equals 15. If x is 0, 3 times 0, plus 5y equals 15. 5y equals 15. 5y over 5 equals 15 over 5. And therefore, y is equal to 3. Now, for our other one, where we have y is equal to 0, we go back to our original formula again, and we get 3x plus 5 times 0 equals 15. 3x equals 15. 3x over 3 equals 15 over 3. And x equals 5. So far, we've been getting nothing but positive numbers. Don't count on that all the time. For example, if you did number 28, where it's 3x minus 4y is less than 12, using the 0, 0 points, you'll find out that, in fact, y equals a negative 3. So it doesn't always turn out that your x and y points are positive, but in this particular case, it's true. So, plotting our points now, x is 0, y is 3, that's right up here. Oops, I want to do that in red. That's right up here in red. And then x is 5 when y is 0 is right down here. And now, because it's less than, we're gonna use a dashed line. we have our dashed line there. Putting an arrow at each end, and that's a good practice for you. Now what we want to do is we want to go back and we want to plot our 0, 0 point. So we say 3x plus 5y is less than 15. 3 times 0 plus 5 times 0 less than, oops, I put less than or equal to, that's not right. Less than 15. 0 plus 0 is less than 15. Is 0 less than 15? By gosh, it is. And because it is, now we shade in on the side of the 0, 0 point, which of course is our axis. So we're shading in all of this and all of this and all of this. When you look in the book, you're going to see a better example of the shading than what I've showed you here. But that's it. You shouldn't have any difficulty with this. It's pretty simple and straightforward. Going to erase, and we're going to talk about a system of inequalities. What I mean by a system is we're going to have more than one equation here. And so what we're going to do is we're going to turn in our books to page 532. And the problem we're going to look at is problem number 44. If you can do this one, no problem. All right? Now, in 44, it says 2x plus 3y is less than or equal to 6. Okay? We also have the other two one, which is x is greater than or equal to 0, and y is greater than or equal to 0. So to figure out that first one, we're using our xy points, x, y, x is 0, y is 0. What do we get? Okay, 2 times 0 plus 3y equals 6. 3y equals 6. 3y divided by 3 equals 6 over 3. And y equals 2. So we got that point. And the next one, using our original formula, substituting in 0 for y, what we get is 2x plus 3 times 0. And then that makes this 2x equals 6. 2x over 2 equals 6 over 2, and x is equal to 3. Now, because it says less than or equal to, what we have to do is we have to use a solid line for this one. And in that solid line, we're going to go x is 2, or x is 0, y happens to be 2, so that's this point here. And when y is 0, x is 3, that's this point here. And now what we're going to do is we're going to draw a solid line there. And we need to ask ourselves, how about the 0, 0 point? Well, 2x plus 3y is less than or equal to 6. 2 times 0 plus 3 times 0 less than or equal to 6. And we get 0 plus 0, which is 0 less than or equal to 6. That's true, okay? So that means we're going to shade on this side where we have the 0, 0. We're going to shade on that side right there. But now we have two other formulas. One is x is greater than or equal to 0. All right, x is greater than or equal to 0. Well, that line happens to come straight across. X is always 0. Okay, it's a solid line, and it's everything, where, you know what? I just drew the other part. I apologize. X is 0, so the x-axis is here. All right? So no matter what the value of x, everything is to the right. Okay? Then when it's y is greater than 0, that's the part where I drew it first, and I didn't mean that. That means that everything in y is greater, all this up here. But now what we say is we want to know what combination fits. We know that everything is going to be north of the x-axis, above the x-axis, and to the right of the y-axis. But it also has to be between the 0, 0 point and our equation 2x plus 3y is less than or equal to 6. That means the only place where everything fits is just this small area down here. And that's graphing 3 inequalities. Everything else does not work because everything to the left doesn't fit one part, everything below doesn't fit one part. So we have to erase all of these because they don't fit. The only thing that fits is what works for all 3 of them. So there you have graphing 3 inequalities.